Okay guys, what's up and welcome back to another video. This is Sukesh Education and today I'm going to be presenting you this slideshow that me and my partner Shriram made for our IST robotics task. So without any further ado, let's get straight into the video. This is our title page. I hope it looks cool because I did spend quite a bit of time on this, but let's keep it going. So this is for my teacher who will be looking at the presentation. So this presentation is also available in the video format. The video format is what you guys are watching, my YouTube subscribers. But let's get started. I named our group, so me and Shriram, the power of S. I thought that was a nice subline to go with it because both our names start with S's and it just made sense. The power of S, and of course, funded by Sukesh Education Inc. Subscribe. So, contents. We have 5 main parts. Only 4, the 5th one's just there, but the first one's introduction from pages 6 to 19, robotics in our society 20 to 40, hardware terminology 41 to 52, innovation in robotics, which is 53 to 58, and an outro 59 to 62. All of these would look pretty cool because we both did spend quite a bit of time on this. So let's get into it. And if you're wondering and you're just watching this video for fun, these 5 dot points are basically the main things that we had to cover in our video, in our presentation. So yeah. Introduction. I'd like to present you a quote by Bill Gates. Bill Gates said that robotics and other combinations will make the world pretty fantastic compared to today. This is what he said. I thought it was quite nice. And then we also have Amit Ray, other entrepreneur. As more AI is entering into the world, more emotional intelligence must also enter leadership. I just thought these quotes were more related to the topic. They inspired me. Hopefully they do inspire you. And let's get into the main fish. The thought bubble of a robot. These were just images that we wanted to add, but we couldn't really find any suitable place. So this is what our thought bubble. Also think there's a nice upward curve that way. So yeah, that's that. Let me actually turn on laser pointer. No, laser pointer does not work. Okay, but that's a thought bubble. And also, right guys, me and Shriram put in so much effort that for around 300 images, 200 to 300 images which are in this presentation, I know it's crazy, every single one of those images, right, 99.85% of those images are with the backgrounds removed. And as you know, if you go search on Google, you don't get the images with the backgrounds removed. We downloaded the image, went onto Adobe, and then, used their AI, and we removed the background for every single one of them, every single. So, just want you to understand that, and let's get into it. So, what is a robot? Many people have different perceptions of what a robot is. People will be like something that's human-like the Tesla bot, or maybe something that, assembles phones repeatedly. Let's look at the proper definition. A robot is a type of automated machine that can execute specific tasks with little or no human intervention with speed and precision. So, robots are machines, right? They don't have emotions, they don't get tired. So many companies want them because it's cheaper labor for them. So, as I said earlier, many people think of robots as machines that look and act like people, but most robots don't do this. Robots are something that people build, right? So, they aren't self-conscious. Most of them aren't. Nowadays, people are trying to bring in more human-like robots that might be dangerous to their society, but we will look at all that towards the end of the video. Now, robot, android, and cyborg. These are just images. A robot, doesn't need to look like a human. It just carries out information. This is a dog that delivers parcel. And Amazon has a similar thing. Then we have an android who looks like human and can typically do most jobs that a robot will do. And then a humanoid is a mix of human and android and can be self-conscious. So this is what, many of us perceive the future to be like. To perceive few of our body parts to made up of robotic parts, because that's just how Hollywood, Bollywood, all these TV entertainment deceives us. That's how they portray a robot. They portray it as a humanoid or a cyborg, But let's get into it. Automated control. Automated control is part B in my assignment, but automated control refers to the process of using computer algorithms, hardware, and software systems to monitor and manage the operation of machines. So, automation in robotics is basically the use of artificial intelligence and robotic technology to automate something. So, it reduces manual labor. So, even if you do have a robot, right, automation comes in where the robot knows what to do when a specific input is put. It knows what to do. It knows to read the specific input and give out an output without any human assistance. So that's just automation, automated control. Now, examples of automated control. Thing is, we got a lot to go through. We're only on slide 10. We got 50 more slides to go. So pause the video, look at this, and let's keep going. Historical perspective. So, what do some robots look like? In my assignment, I was asked to, include images from Hollywood and the scientific community. So, this robot kind of thing is from the Hollywood. This used to be from Hollywood, but now we do have these things now. These are Amazon's parcel delivery guys. Moreover, just called dog robots. That's the common public name commonly referred to. This is Zipline, very inspirational story. Go watch a Mark Rober video. So Ziplines, these basically used to travel and help in the medical side in less developed countries like Africa, countries like Uganda and stuff in Africa. But now it's being used in the US for food delivery purposes. Then we have scientific. So this is how more of what the scientific perspective of a robot looks like. Not really as flashy, jammy, scientific again. So examples of a robot. So we have some basic examples of a robot here. A Delta robot, Cartesian robot. As you can see, these look nothing human-like. Now pause the video, read the information, and let's keep going. I can't read it with you because of the time delays, but let's keep going. There's also polar robots and a mobile robot. A mobile robot is very interesting, so I'll read that to you. So it's something that can autonomously control itself and navigate without any human guidance. I think we will be building a mobile robot. I'm not yet sure, but we shall see. Now, I have a YouTube video on, how do some robots look like. This is a PBS documentary, very entertaining, only 9 minutes long as you can see. Click on the link here, takes you to the video. But in the video, scientists and engineers basically discuss about humanoid robots, discussing about the possible benefits, what can happen if anything goes wrong, thinking about it in an ethical perspective. And also, all these robots, right, the human-like robots, they're being built, as per Hollywood portrayal, because that's when the audience would most, understand it's a robot. They don't want to make a robot too human-like, because then we'll be unable to differentiate a human and a robot, which then all starts into a massive disaster, and that could be the end of the world in my opinion. But let's get going. That's why they make these robots very much so that we can differentiate them as soon as we see them. Like if they want, they can make it human like the facial expressions and everything, but they won't. So yeah. Now moving on to our next bit, subpart. Who is Asimov? Asimov is an American novelist who was born in Russia. But that doesn't matter because he's popular for his science fiction writings. He's also a professor of biochemistry at Boston. He produced more than 500 books, and the main reason he is famous right now is because of his Robotics Series 3 book, which went through the 3 fundamental laws of robotics, which we'll see in the next slide. So, what are Asimov's 3 laws of robotics? So, his 3 laws of robotics are in collection of fictional instructions created by a science fiction writer, Isaac Asimov. So, his first law is that robots should never harm people. They should never threaten or attack or kill people. Now, the second law stated is that robots must obey orders given by humans unless those conflict with the first law. And the third law is that a robot must defend its own presence unless conflicting with the first or second law. Right? So these are Asimov's 3 laws, and these are the fundamental identities or fundamental theories laid down for robotics, and every, robotic engineer or designer sticks them to memory and they follow this. They can't, because you don't want a robot to go take over the world, do you? People don't really think much and they say, oh, if you recall, release robots are going to take over the world. We are giving them the ability to take over the world by letting them be self-conscious. As long as we don't do that, no one's going anywhere, and robots are there to help us with the mundane tasks. Okay, now why did Asimov put these 3 laws of robotics he did? It's just in order, he predicted that this is what's going to happen in the future, and he's a science fiction writer, so he doesn't really know anything. So, sorry, that was dumb, that made me look dumb. He's a science fiction writer, so he uses imagination, so in the worst case of a zombie apocalypse kinda theme, he made these. Guys, I'm joking. Of course not. Go research on Google why. But, are they realistic laws though? Of course they are. The use of the terms harm and injury can be interpreted by the law variably. We do not know what those mean for sure. There's also unintended consequences. So the law does not take into account the undesirable consequences that may arise from the robot's action, because its third law states that the robot needs to defend itself. So what? Will a robot go and kill the human in order to defend itself? Is it okay for a robot, a non-living thing with no emotions, to kill a living species? I don't really think so, but that's what we're discussing under are they realistic. Laws can also create situations where compliance with one another is less, and actual implementation. So implementing all this in the real life is challenging and complex. That's why even the Tesla bot, which was announced a year ago, still has no updates, and it still won't for another 3-4 years. Now, moving on to our part B. Robotics in society. Yeah, just took a quick water break. Now, hope you guys like this title slide too. Robotics in society. We both are pushing the word. Let's get into it. So, purpose. Under the purpose, we're going to discuss when were the first robots used, what were the different industries they're used in, etc., etc. So let's go. So, when were the first robots used? So robots have been used in different forms throughout the history, but the concept of modern robots emerged in the 20th century. The term robot was coined by Czech writer Karl Apek in the play R.U.R. in 1921. The first industrial robot, called Humanoid, was introduced in 1961 and is now used in many industries, including manufacturing, healthcare, space exploration, and entertainment. Do you guys know what Humanoid is? If you don't, tell me down in the comments. But let's look at the timeline of these industrial robots. So in the 1947, the first Stanford arm was developed, becoming the first electrically powered robot arm. This was a major breakthrough, allowing other people to take inspiration and carry the leap. And in 1997, very soon after, because we are speaking this in terms of technologically, in 1997, Honda introduced ASIMO, an Android robot designed to mimic human movements and assisted tasks. And then in 2004, the Boston Dynamics introduced a big dog, so the quadruple thing, what we saw there. And then in 2015, SoftBank Robotics releases Pepper, a humanoid robot designed for human interaction, equipped with facial recognition, natural language processing, etc. But nowadays we have, I forgot to add that 2021, but nowadays we have a robot called Sophie. So Sophie is this robot with wonderful, she looks like a human. That's what, you can see that SoftBank's robot doesn't look human-like. She looks like a human, but that's that. Why are robots important though? So robots can consistently produce standardized and reliable results by following programmable instructions. They can also help you be more efficient, and they can do their job, so the boring, mundane tasks, highly efficiently with high precision every single time. They don't get tired. If you want them to work during the night, yes, you can. Plug in the battery, they're going to keep working. That's just how it is. Now, innovation and advancement. So HUDs are constantly working to improve the capabilities of robots, contributing to the progress of science and technology. So the more people that work on robotics, the better robotics in general is going to get, because of the competition and because at the end of the day, everyone's learning from each other to make the society a better place. So let's look at our next slide. Now, robotics are also important for exploration. So robots play a huge role in this space. So they can gather valuable data from other investigations. So robots, right? They're just machines. So the space probe has this robot inside that constantly monitors, takes photos and everything. So also increased quality of life and reliable results, as said previously, and improved safety. Robots can be deployed in hazardous environments such as handling toxic substances or navigating dangerous terrain or even mining. And look, if something bad happens, it's alright. We didn't lose a human life. A human life is impossible to recreate, whereas a robot is alright to do so. So we can put them in the mines where, they're not breathing in, so it's all good. Now, robots in dangerous jobs. We have some examples to show you. So this is a robot clinging into a building wall. I know you can't see it properly. It's a technical glitch from my side, but just imagine that in your brain. And then we have a mining robot. So these robots are used, a little bit there and there. And then we have a prototype of a humanoid at a work site. So this humanoid was by, I believe, SoftBank too. And yeah, they have a prototype that I don't really think they were, actually, it's actually in place right now, but it was there for the shot. It did a few work here and there, picking up, digging out the sand and everything. There's a very cool YouTube video on that I'll post in the comments. Now, what different industries use robots then? So that brings us to the next point, types of robots point. And look, the funny thing is, we're only 27 pages in. We have half more to go. So let's keep this rolling. What different industries use robots today? Okay, so the automotive industry definitely uses robots, because robots are manufacturing plants for a variety of tasks, including building, painting, blah, blah, blah. And then the aerospace and the aviation industry, as I just said. The healthcare industry, because surgical robots assist surgeons performing minimally invasive procedures for increased accuracy and better patient outcomes. So you definitely won't be seeing, even in the future, so even 2020, even 2050, right? You won't be seeing robots taking over doctors, because robots are not going to be playing with human lives. No one feels safe. I definitely wouldn't, and I don't think you would too. Now, there are a few more industries. They're in the education industry, logistics and warehousing, agriculture. Now, when I say the word logistics and warehousing, I think that's something that everyone knows, because, There are big warehouses. You got robots moving everything around. You might have seen it on YouTube too, some of Tesla documentaries. But that's that. Education. Robots are increasingly being used in education and research institutions to enhance the learning experience and conduct experience. So this new technology came out recently called ChatGPT. Now, ChatGPT is being used by my school. They do give me tasks, even in history last week, to use ChatGPT, research, and summarize my points. So, basically, if you use technology and AI to appropriately, it can be very beneficial to you. You don't want to go and copy paste an entire essay, not because you shouldn't, you're not learning anything from there. And let's say you do get into uni or something, you don't really have the skills that you portrayed to have, so you're gonna fall behind, go into depression, and many students who go into depression is a death. But I'm saying the worst case scenario, but just don't do that. Now let's go, because we sidetracked a bit there. Robotics industry. So I just told you the 6 industries, but these are images there. We can see automotive industry, so like assembling cars and everything. Aerospace, so yeah, in the space, taking photos. Healthcare, just assisting doctors. They're in the education industry, assisting students here and there. They're in the agriculture and the logistics. Sorry for that. But that brings us to select a robot and research a specific use. My team chose the SCARA robot, the Selected Compliance Assembly Robot Arm. So this is a robot that can do something repeatedly, or that task like screwing in screws, packaging something, but it can keep doing it repeatedly. So it's very highly efficient. So Toshiba machine used in Japan. But let's go. Specifications and uses. So the SCARA robot have 4 degrees of freedom. What are these 4 degrees of freedom, you might ask? But I will go over degrees of freedom in the very, very next slide. Yeah, I said very, very 3 times because it's 3 slides down. But these degrees of freedoms allow the robots to move horizontally and vertically, as well as rotate and tilt its end vector. And uses. The SCARA robots are used in assembly lines for tasks such as embedding components, mounting screws, and soldering. Their speed and high precision makes them ideal for high volume and production environments, as I said earlier there. Now, specifications and uses of the next one. These are all SCARA robots. I just thought these different images look cool. Like, this one looks so good in 3D, right? Specifications. So it can also handle a wide range of payloads from a few grams to several kilograms. The payload capacity differs based on multiple variables. Now the uses. They're used extensively in packaging applications, including picking and placing operations, product sorting, and packaging material handling. They can quickly and precisely control objects and place them in specific locations. That was a lot to read through, guys. But this robot looks so cool because, this is used for PCB assembly. So Apple kind of uses this in their CPU kind of arranging. Guys, I've been speaking for 30 minutes. My voice is dead. But I'll still keep going. Specifications. It has a limited operating range compared to some other type of robots. However, they are designed for applications that require accuracy and speed rather than an extended range. So these are slow, take the time, but they're very, very accurate. You can go into say 99.95% accurate. No, 99.99. Yeah. But yeah, and they're commonly used in electronics industry such as the printed circuit board, PCB, or soldering operations. Now, wow, still here. SCARA robots are used in a variety of industries. They include Seiko Epson, Yamaha, blah blah blah. These are all just companies that use them, but yeah. Now, what are degrees of freedom? So degrees of freedom, as you probably got a hint there, is basically how it can move. So the 6 degrees of freedom is a concept used in physics, robotics, and computer graphics. So it describes the ability of an object on a system to move or rotate along the X, Y, and Z axis. So it can move up, down, left, right. It's just how it works. So this is essential. Why is this essential, you might ask? Because most of these things are coded or developed on computers, right? So for us to be able to control its actions and everything and make it as realistic as possible, we need these degrees of freedoms. So this is essential for various applications such as virtual reality, flight simulation, video games, multimedia, design, mechanical robotic engineering, space tracking systems, blah blah blah. It just makes it more efficient, productive, and smart because you can see the 3D like 3D view right there. Now, for a type of robot, we picked the iRobot Roomba. I found this very interesting and it also looks pretty cool. Yeah, so this is basically just a robot that can, map out the entire room using sensors it has, and then automatically go and clean when it needs to with a click of a button from your phone. How cool is that? So, the Roomba charging. This is just how the Roomba charges. I know it's a pretty horrible image. Like, the green thing is not actually there. It's just showing you the flow of how it charges. But, yeah. Oh, of course, we got the spin animation. Now, specifications. So, the specifications of the Roomba include cleaning system, sensors, navigations, and battery life. So, it has a dual multi-surface brush with edge sweeping brush and suction power as a normal vacuum. Sensors, so cliff sensors to avoid fall, dirt detection sensors, bumper sensors, lots of sensors, guys. Navigation, it has this IDAP navigation technology. So it basically uses some sensors there to map out the entire room. So it knows where to go next time. And then the battery life, it varies by model, but it can go from 60 minutes to 120 minutes. So that means it can clean for 120 minutes at a time. Like, I put my vacuum on for like possibly 10 minutes a month. No, 20 minutes a month for all 3 rooms that I have. So 60 minutes, that's next level, guys. But let's look at it. Uses: efficient floor cleaning. The Roomba automates the process of cleaning floors, removing debris from the surface. So you don't really spend time by cleaning. These boring, mundane tasks. That's why we got the robot to do it. And then time saving. By cleaning the floors, the Roomba saves time, effort, and increases quality of life because when you come back from work, your house is clean. You're just going to be in a much happier mood, not having to clean, sweep, wipe, blah, blah. Now, maintenance. The Roomba helps maintain a clean environment by cleaning floors, especially in high traffic areas. So, these are a must buy for office case scenarios. Small businesses. Yeah, buy a few of them, put them around your office. Your employees will feel valued. You'll feel happy. It's just a much better working experience. You don't want to be working in a slum dirt kind of area, do you? Okay. Now, automation. The impact of automation in the cleaning industry has brought numerous benefits to the users, ranging from time saving, convenience, advancements, and increased technology and productivity. So this is another, robot. But basically all iRoomba kind of robots have an app that maps out the entire home, as you can see here. And you can, with the click of a button, it can go to the room that you want it to. So that's pretty cool. Like, not pretty, very cool. Now we're moving on to hardware terminology. Guys, I gotta take a break, but I'm not. How many slides? 20 more. Okay. Hope you like this, title page. Okay. So, hardware terminology. Wait, guys, I will actually go one sec. Okay, guys, back from my break. So, hardware terminology. Let's grind them. So we have 3 parts in hardware terminology, right? So one's types of sensors, actuators, and control and feedback devices. This This next sections are going to be very short. So let's go have fun. Types of sensors. So there's general sensors and there's EV3 sensors. So EV3 is basically a popular robotics platform developed by Lego for educational and hobbyist purposes. So it comes out with various sensors that allow the robot to gather information about its environment. The touch sensor detects physical contact. So the color sensor detects a wide range of colors and light intensities. Then we have the general sensors. So the general sensors are devices that detect and respond to physical input or environmental conditions, converting them into measurable signals or data. So as we see, we have some examples here of a general sensor and an EV3 sensor. So EV3 sensor is just basically by Lego. So the types of EV3 sensors include touch. That is what I'm going to be going into. What is the effectiveness of this? So it's a simple input detection. It's versatility. No, versatility. Whoo! It's versatility. Okay, I gotta really improve my English, and real-time responsiveness. So, simple input detection is the touch sensor excels in detecting physical contact. We can use this for a robot. I hope you like this nice reflection of this image because, yeah. And then the sensor can be attached to various parts and can be used to perform various applications. Now, the real-time responsiveness, the touch sensor provides real-time feedback, enabling quick and immediate reactions from the robot on physical contact. So you can program your robot to be like if-then statements. So, if physical touch is encountered, then deploy sound siren. Something like that, We're using the sound touch sensor to perform other tasks. Now look, what are its limitations? So the binary output is one significant one. So the touch sensor has a simple binary input, indicate whether it's pressed or released. And then the limited sensing area. The sensor surface is so small that it can only detect touch within a confined space and vulnerable to false triggers. So touch sensor can be susceptible to accidental triggers or false readings. And then also a lack of environmental sensing. So unlike some other sensors, such as ultrasonic or color sensors, the touch sensor doesn't provide information about the robot's environment beyond physical contact. Then, as we said, that's EV3 is there. And then what are actuators? In general and in EV3s. Actuators are devices or components that convert electric or mechanical energy into force. So they're a crucial part of robotics as they enable machines to interact with the environment. Now, EV3. Actuators in the EV3 Robotics platform are essential components that convert electrical signals into mechanical motion, enabling the robot to move, manipulating objects, and interact with its surroundings. Now, the types of EV3 actuators. We got the motor, the NXT motor, the linear actuator, and the medium motor. I know this all seems very weird, and I'll admit, it seems weird to me too, because I haven't actually used them. But ask me a question next time, and I'll give you all the information you want. So again, this is a control device. So this is where the brains of the EV3 happens. You can connect using these ports to your laptops, keep this on your, project, use it. So a control device are components or systems that regulate and manage the behavior of devices. So it records what happens. So they can be classified into two things, open loop or closed loop systems. So in an open loop control system, the control device sends commands or signals to the control device without monitoring its input. So a closed loop control system. The controlling device constantly monitors outputs and gives feedback. What happened? Okay. Now EV3. Wait. Don't tell me it's the same image. Yeah, okay. It's black flipped. So EV3. So the EV3 robotics platform uses an open loop control to execute pre-programmed sequences of actions without actively sensing or responding to the environment. So closed loop control is achieved through the use of sensors, feedback mechanisms such as a touch, color, ultrasonic, and These sensors provide data about the robot's environment or its own state, which can be used in the control program to alter and adjust the robot's behavior. So, moving on to our example of an EV3 robot. This is one very good example. This is what I want to create next term. Just look at how cool, manly, and how spiky it looks. These are things that I'm into. Like, this looks next level. Using sensors there, touch sensor there, touch sensors on either side. This is next level. And then, of course, you can make something like the scorpion kind of thing too. But that brings us to our last bit, guys. How exciting are we all? Innovation in robotics. Fun. So, the future of robotics. So, I'm just going to go through 2-3 timelines here. So, within 10 years, right, we would see an industrial automation, hospital management, and personal assistance. So, they're basically telling us that we can go into hospitals, no doctors, it's just all automated, so it's AI. It asks you, cues you your thing, and then you're left out. I think this is unlikely, but according to research and specialists, this is what's going to happen in 10 years using robots. And apparently 20 to 30 years later, robots will be used in elderly care and autonomous transportation. So, such as your train lines and everything, we can use robots as drivers. This is just really sad because it's going to be taking away more and more jobs. If robots replace everything, then humans, they really have nothing else. So, really got to plan this all out properly. So about 20 to 30 years, they'll be using elderly care to take care of them. In the far future, robots will be used to explore deep space, advance healthcare, and manage the environment. So be more like a human, let's say. But that's robots in the future. So even though jobs may decrease for humans, robots will not destroy people since we don't need to make them self-conscious, right? Remember, only if you make a human self-conscious, aka a cyborg or a humanoid, are you allowing it to actually, make decisions on its own. But we're not going to do that, at least for a long time, but to avoid the risk, to mitigate the risk of unwanted incidences. So, this thing is what concerns me. Jobs decrease for humans. Because, see, we can technically make a robot for every single job you want. Do you want a plumber? We can make a robot. Do you want Prime Minister? We can make a robot for that. Knows every single thing at the back of his mind. So if you get robots to replace everything, then there are no jobs for humans. So humans have to be the creative thinkers and think. They have to be making the robots. But then if you make robots reproduce, so like robots make another robot, humans really have no job then. So that means there is no use in a company existing because no one has any money. So therefore no one's going to buy any, services of the company. And that's just when the world ends. So let's see. Future robotics in society. So the use of robots is expected to have a significant effect on society, such as job displacement, economic productivity, skills, education, and human-robot interaction is definitely going to increase. As I was saying earlier in the video about the Sophie robot, this is the Sophie robot. I know. They didn't really, cover this bit off because they still want you to think that it's a robot, right? They want you to believe it's a robot because otherwise humans can get confused and this just goes down another rabbit hole where everyone's confused. And then automation can lead to job displacement in certain industries, aka many industries, while new job opportunities can emerge in areas relating to robot design, maintenance, programming, and supervision. That's not really going to happen if we let these robots supervise themselves, program themselves. If we give them that ability to self-consciously, do whatever they want, all this can happen, and this is where we get out of place. So, economic productivity can be enhanced by increasing efficiency, reducing errors, improving output quality, and therefore the robot benefits society and can create a better future for generations to come. So, it's all just how we use the robots. So, if we use it properly without taking too many advantages, just use it for mundane, boring tasks, and use it productively, we can actually help. We can actually get so much from these robots that it's gonna help us sustain our life and propel it forwards and make future generations prosper in the brightest society that they can. So, the future of robot and humans, as I said, it's just this image. Now, many of you might be confused. Okay, yeah, sure, I know this is a robot. Is this guy a robot? Is he, guys? Is he? I know, very tricky question. He actually is a robot, but I wouldn't be surprised because my first time when I saw this image, I thought that man was a robot. Just look at his facial expressions. So, we need to be able to identify. And then, as I said, the power of S was the subline that I wanted to go along with this my presentation. So the power of S is Sukesh and Shriram. But yeah, so just all our images here. I did slides 2, 3, 4. I just did the even sides. He did the odd slides. We just did alternating. So he did 1, 2, 3, 4, 5, 6. So it's very even. It's like 50-50, but exactly 50-50. And just some bloopers for you guys because he stayed till the end. And, we got the bibliography, just a few. And then we have more bibliography available at our Google Doc because we don't want to bore you with bibliography, like 5-10 slides of that. So click on this link and it'll take you to more bibliography. But that brings us to the end of the video. So this is my ending. I know, no sound. It's all just to say the end. Right, with that being the end, I'm going to say the end to you. Thank you so much for watching this. Make sure to hit the like and subscribe button. And if you did stay old as well, thank you so much for being so involved into my IST presentation or just in my channel in general. I'm going to be dropping as soon as I get my marks back, supposing that I get an 80% and above. As soon as I get that, I'll be dropping a linking my presentation here so that you guys can use it as a template in the future. So with that, have a good day.